This is the video in continuation with the previous one, which deals with the stoichiometric relationship. So now we are going to look at how to calculate the concentration of the unknown solution. So N is equal to concentration multiplied by volume divided by 1000. This is what in the last video we saw. So we are going to use this, and we are going to use this one also. Concentration is equal to number of moles by volume. We are going to use this also. So let us use both to calculate the concentration of an unknown material. Okay, let me take an example. An aqueous solution. Aqueous solution is the solution in which water is the solvent. 25.0 centimeter cube of sodium carbonate of concentration 0.0200 moles per decimeter cube is titrated with hydrochloric acid. The volume of hydrochloric acid required to exactly react with the sodium carbonate is 12.50 centimeter cube. Calculate the concentration of the hydrochloric acid. So how to do this? First we need a balanced chemical equation. Sometimes you may not be given the balanced chemical equation. We need to write the balanced chemical equation. What is the reactant? Sodium carbonate. We need to know the formula of sodium carbonate is Na2CO3. It is in the aqueous solution. I am teaching side by side the balancing of equation also. Then you have the hydrochloric acid, which is also an aqueous solution, HCl aqueous. Then the products will be sodium chloride aqueous plus carbon dioxide gas plus water liquid. If I want to balance, there are 2 moles of sodium, so I need to have 2 sodium chloride. So there are 2 chlorine, so this time it is 2 HCl. So now the equation is completely balanced. So how to do this? Here there is no direct given of number of moles. They have given only the concentration. So this is the volume of sodium carbonate given. This is the concentration of sodium carbonate given. So number of moles of sodium carbonate first I need to know. So number of moles of sodium carbonate is 25.0 centimeter cube, that is the volume. Concentration is 0.02. The volume is in centimeter cube, so I need to convert it into decimeter cube. So 1000 divided by 1000, because 1000 centimeter cube per decimeter cube. So you will get the number of moles. So how much it will be? 25 multiplied by 0.02 divided by 1000. So which is equal to 5 into 10 to the power negative 4 moles. So now I am going to take the ratio. It's similar to the previous video where we do mass ratios. So again, what I have is Na2CO3 is to HCl. 1 is to 2, because there is no number, it means 1, and here it is 2, so 1 is to 2. So 5 multiplied by 10 to the power negative 4 is to watt. So we know that X will be equal to 2 times 5 into 10 to the power negative 4 divided by 1. So which is 1 into 10 to the power negative 3 moles. So I got the number of moles of HCl reacting. I know the volume of HCl. The volume of HCl is given 12.5 centimeter cube. So if I want to get the concentration of HCl, the concentration of HCl is equal to number of moles by volume. Then the volume of HCl has to be converted into decimeter cube. So 12.5 divided by 1000, because 1000 centimeter cube is equal to 1 decimeter cube. So you are going to get 12.5 divided by 1000. So you are having 0.0125 decimeter cube. So now the concentration of HCl, number of moles of HCl over volume of HCl. Number of moles of HCl, here it is, 1 into 10 to the power negative 3. Volume of HCl 0.0125. So which will be equal to 1 into 10 to the power negative 3 divided by 0.0125, which is equal to 0.08 moles per decimeter cube. So you need to know the unit. The concentration unit will be moles per decimeter cube. So what I did is I found the number of moles of number of moles of one of the reactants from its concentration and volume. After getting that number of moles, I took the ratio of the other reactant, which is unknown. Here it is HCl. Now I found the number of moles of HCl reacted. Once I know the number of moles of HCl reacted, once I know the volume of HCl, then I can find the concentration by moles divided by volume. One important point I need to have is I need to always convert the centimeter cube into decimeter cube. I hope this helps you to find out the unknown concentration and as well deal with the solutions in stoichiometry. I want to do one more example based on gas volumes. How to use gas volumes. So that I am going to do now. Let me take one example which helps me to connect with the number of moles, volume of the gas and as well the mass of the gas. So let us do that. I am taking this example. Calculate the volume of oxygen at room temperature and pressure that would be required to convert 5.2 decimeter cube of carbon monoxide to carbon dioxide. Carbon monoxide to carbon dioxide. So I need to know the equation. Carbon monoxide gas reacts with oxygen gas to give carbon dioxide gas. So I have to balance 2. Now I am given the volume, I am not given the number of moles. I need to convert it into number of moles. So number of moles of carbon monoxide, which is equal to volume divided by 24. Here I am not converting because it is already given in decimeter cube. If it is given in centimeter cube, I need to convert that centimeter cube into decimeter cube. So 5.2 divided by 24. What I am getting is, I am getting 0.217 moles. So now again I can say the ratio, because they are asking volume of oxygen. Carbon monoxide is to oxygen. It is 2:1. What you have is 0.217 is to x. I want to find that x. So then the x will be equal to 1 multiplied by 0.217 divided by 2. Actually it's a cross multiplication, so that is what we are doing. So when I multiply cross, it will be 2x is equal to 1 into 0.217. So x is equal to this 2 will go this side, it will divide, so that's why I am getting this. So 0.217 divided by 2, which is equal to, I am getting 0. So number of moles of oxygen is equal to 0.1085 moles. But they are not asking number of moles, they are asking volume. So I go for volume. Volume of oxygen. Volume of oxygen is equal to 0.1085 multiplied by 24 decimeter cube. Because we know that number of moles is equal to volume over 24. So this formula only I am using. When I rearrange, number of volume is equal to number of moles multiplied by 24. So I multiply it by 24, I will get 2.604 decimeter cube. If they are asking mass, you will multiply the number of moles by molar mass. So I hope these two videos gave at least some extent of understanding to calculate or to determine many things. Basically the concentration, the number of moles of the reactants and products required, the limiting reagent, how to deal with the volume of gases, all these things have been covered in these two videos. Kindly go through. Many times if you watch, you will get a clarity on every time, so you can do similar problems with comfortability. Thank you for watching.